This week, we're going to look at rational functions. And as soon as we start, rational functions just means a polynomial divided by a polynomial, or as we can see here, all right, something in the denominator. So what I want you to see, as soon as we type in 1 divided by x, and again, the numerator can be anything as well. So we'll get there, but we're going to start with kind of the most simple. And I want you to see that we automatically see this shape. And if you are unfamiliar, what this is called right here, right, this kind of vertical line that the graph does not cross, right? You can see how this gets really, really close, and we can kind of zoom out, wrong way to zoom. Let me clear those annotations, sorry. Right, if you keep scrolling, it kind of looks like it's there, but if you zoom in, right, this function, this graph, the red line is getting close and close to, this is the y-axis, but it's not actually touching it, and it never will. And that's the definition of what's called an asymptote. And so in this case, because it's a vertical line, this is called a vertical asymptote. And an asymptote is just that this line that the graph, this function, will approach. And again, you can see it's actually going in both directions, all the way to positive infinity and all the way to negative infinity. And so so when it gets close like that and it's approaching this vertical line, it's called a vertical asymptote. In this case, we can also see, going left and right, this one also has what's called a horizontal asymptote. And one thing I want you to know, just like with like the axis of symmetry, each of these is a line. So the vertical asymptote in this case is the line x equals 0. And just because of this function, the horizontal asymptote is y equals 0. They're not always going to be both be 0. We're going to explore that in 1 minute. But this is how we write the equation of an asymptote. It's the equation of a line. And so a horizontal line is y equals the number, and the equation of a vertical line, right, is x equals a number. So that's what we see when we just have 1 divided by x. If we clear this, and maybe it's not just x, but what about if x, and maybe it's plus any number, a. And so or even, I think in your sheet it says minus a. Either way, it works the same. So we're going to investigate. You can check out both positive and, or plus a and minus a. And so I just want to make that so we can see each of the numbers here. So have a look at where this asymptote looks like it's going. Look at this direction. I'll stick in green for the vertical ones, right? It's going very, very close to, not in this case, not to 0, but to this vertical line of x equals 1. And that's not a coincidence. It's because right here, this graph, if we plug in 1 for a, is the equation y equals x minus 1. And so the vertical asymptote is here, where the denominator is 0. So it's kind of like solving for the zeros of the function, but in this case, when you're solving for the vertical asymptotes, or really where we're going to talk about where this whole function is not defined, well, this function right here is not defined when the denominator is 0, right? Because we can't divide by 0. And so but we're going to use the same exact algebra techniques to find these points of discontinuity. That's kind of the new language that we're going to see. So we can have this discontinuity, as an asymptote, or we're going to see it in another form soon too. But so let's take a gonna clear this. And so I made this a slider so that way we can see, right, this, and I'm gonna maybe try to zoom out a little bit. As I move the slider, I want you to notice, right, when the slider's at here at 5, right, here's my vertical asymptote right here at 5, right, because at this point, when this is now y equals 1 over x minus 5, and so, right, if x equals 5, then my whole denominator, then we get y equals 1 divided by 0, which is undefined, right? We can't divide by 0. Dividing by 0 doesn't exist. It's undefined. And so that's why we get this shape of this graph, this vertical asymptote. And that's going to be, we can keep this slider going all the way, right? We'll see it moves all the way to 10 when a is 10. And likewise, if it's negative, right, we can have negative ones all the way to -5. Oh, if I can get there, right? Here's my vertical asymptote at y equals -5, because we have this x minus a -5, or, right, x plus 5. So x equals -5 is a vertical asymptote. You can abbreviate that to VA. And that 5 is not very, let's see. So, and so you can slide that around, play with that. But now what I want us to see is things can